So to be honest, it saves me time because you usually ask, oh, can you provide us more problems? I think it's more useful for you to have access to actual video of, doing the problem. Obviously, you're not going to be seeing my face, which I don't think much of a loss. But you're going to see how we're going to fill it out. So let's start working on the problem number 1. Come on, dude. There we go. So problem number 1, right? What we have there? We have 1 milliliter. And sorry, I'm not looking at you because I have to focus on the page. 1 milliliter of whatever sample. Questions? No, all good? Just let me know of something. 1 milliliter of a sample that is placed essentially in a petri dish. Okay? And after the incubation, what do we get? We get 82 colonies. Right? Now, in our future conversations, instead of a term, a colony, we're going to use a term, colony forming unit. So we got 82 colony forming units. So this 82 colony forming units came from 1 milliliter of a sample, which means that the sample concentration is 82 colony forming units in 1 milliliter. Or it is complete equivalency, 82 CFU per ml. Okay, that was simple. Let's get to the problem number 2 when we introduce the concept of dilutions. So 1 milliliter of milk is added to some saline. Specifically 9 milliliter of saline. Would you agree with the statement that milk got diluted? Yes? Yes? Okay. And then we take this dilution and we add 0.1 milliliter of it onto the petri dish. This is like, I'm just reading the problem right there. Okay? And out of this, we get 200 colonies, or colony forming units. So how do you calculate the concentration of bacteria in the sample? So first of all, the first question that you have to ask yourself, these 200 colonies, in which volume did they come? They came in 0.1, right? This 0.1 milliliter contained 200 CFU. So we can write down that 200 colony forming units were found to be in 0.1 milliliter of the dilution. How did I get 200? It's right there in the notes. Second problem. Okay? Go on. That, no, wait, we diluted, right? We did not add milk to the plate. We added diluted milk to the plate. Now we need to find out how many colony forming units are in 1 milliliter of undiluted milk. To do this, we're going to introduce the concept of a dilution factor. Now, I think that my definition of a dilution factor is more convenient to work with than the definition that is given in your lab book. My definition of a dilution factor, or DF, is that it is the ratio between the volume of sample plus volume of solvent, saline, water, whatever, divided by the volume of sample. So for this particular problem, dilution factor will be, what is the volume of a sample? Sorry. What's the volume of a sample? What? No. What was the sample? 1 milliliter of milk. So we can put it here and here. What is the volume of solvent? 9 milliliters. That's how much saline we used. Okay, clear? Good? All right. So 10 over 1 gives you 10. Yes? Well, this is 9 ml. This was given us in the problem because this is the volume of the solvent. Okay? So it's 10. Now, in order to calculate the sample concentration, we need to multiply this by the dilution factor. So we're going to multiply this by 10. So if you do all the math, it is 20,000 colony forming units per milliliter. Questions about this part? Okay. So this is going to be your answer. I'm going to put answers in the squares, rectangles rather. And that brings us to the problem number 3. So again, now let's have a chat. How much blood is added? So 1 milliliter of blood. What is the volume of saline that is used to dilute that blood? 99 ml. So this is your dilution. What is the dilution factor then? Let's write it down. What is the volume of a sample? So 1 ml goes here, and 1 ml goes here. And what is the volume of the solvent? 99. So 100 over 1, meaning 100. So far, so good? So now, we're loading what volume of that solution, okay, of that dilution, what volume of that dilution we are using to plate on agar. 0.01 gets plated on the agar. And how many colonies do we get out of it? And we get, and we get 40 colony forming units. So, by the way, it is recorded right now and it's going to be posted in the Blackboard. Whatever, Brightspace. I can get used to it, okay? So, sample concentration. Can someone tell me what I need to do? What I need to write in the first fraction? 40 colony forming units that were delivered to the plate by which volume of the dilution? 0.01. So you divide it by the volume that was applied to the agar and multiply by 100, the dilution factor. Okay? Again, if you do the calculations, 400,000 colony forming units per ml. Okay, now, if you excuse me, problem number 4 is not worth of putting on any kind of media. If you take 5 milliliter of a sample and mix it with 20 milliliters of saline, what's the dilution? Remember what goes up on that fraction? Volume of saline plus volume of sample. It is 25. What goes on the bottom? Volume of a sample, which is 5. Does that make sense? Okay. Sorry. Dilution factor. The definition. Hear me out. Volume of the sample plus volume of whatever you diluted in divided by the volume of the sample. Everybody agrees? This is what we were talking about. What is the volume of the sample in the problem? 4. Yeah, it is 4. My bad. Huh? What is the volume of a sample, folks? It's written, huh? 5. What is the volume of saline? And 5 goes in the bottom as well. 25 over 5. Good? Problem 5. Sample is urine. Everybody agrees? Okay, this is right. And we added to 30 ml of water. What is the dilution factor? Nope. The dilution factor. How do we calculate the dilution factor? It's right above the problem 5. 6 plus 30 divided by 6. 6. Right? Now we take how much? 0.1 milliliter of that dilution and load it on the Petri dish. And what's coming out? And 109 colony forming units. So to calculate sample concentration, what do we need to do? 109 colony forming units were delivered to the plate in what volume? 0.1 ml. And what is the dilution factor? So it gives you 6,540 colony forming units per ml. Yes. Yes. Multiplied by 6. Questions, folks? Ask them now. Because I will, this is pretty much, this is a live recording. I'm recording everything that's going on in this room. So people from 2 p.m. class will be able to hear your questions. Maybe they had the same questions. This is why I encourage you to ask. Okay? All right. Well, let's do the problem number 6. What is the volume of a sample? 0.1 ml of blood. How is it diluted? In 9.9, right? Why I'm asking, not because I'm blind or an idiot, but I sometimes can look at a different problem and mix something up. This is why I ask you to verify. So 9.9 milliliter of saline, whatever. This is your dilution 1. Everybody agrees with that? Because you're going to dilute it one more time. What is the dilution factor for this? No. No. What is the dilution factor? How do you calculate it? This divided by 0. Yes. Yes. So this is what we have there. 10 over 0.1, which gives you 100. And what do you do with that first dilution? What do? You dilute it again, right? If you read the problem, we take 0.1 milliliters of dilution 1. Okay? Can you see that in the problem? And we add this to another vial which contains 9.9 9.9 milliliters of saline. Sounds good? What is the second dilution factor? What? Is this dilution any different from the first one?
No.
Well, the same, of course. So dilution factor 2 is 100. Now we need to plate this. Right? What is the volume that we're plating? 1 mil. 1 ml. And how many colonies do we have coming out of it? 24. So, what do we do about sample concentration? Well, we're going to take 24 CFU, right? And they came from which volume? Not which dilution, but what volume carried them? Which volume did we add finally to the agar plate? How many milliliters did we plate it? Don't look at the screen. Look in your problem. It's written there. What was the volume that we plated? Say again? 1 milliliter of the second dilution is plated. Okay? So, this 24 colony forming units came from 1 milliliter. And now what do we do with two dilution factors? We multiply them. So we multiply 100 by 100. Okay? And that gives you 240,000 colony forming units per ml. Okay? And the seventh problem. I can tell you that nothing more complicated than the problem number 7 can be on your lab quiz regarding the dilutions. So this is the absolute ceiling. What is the volume of initial sample? 1 ml. So what is the volume of the diluent? 9 ml. So what is the dilution factor? First one, It's 10, right? It's not, dilution factor does not have any units. It's a unitless, so it is 10. Then you take a certain amount of that first dilution, right? What is that amount that you take? 0.1 milliliter, very good. You take it and you add to another vial, right? That contains how much water? So what is the dilution factor then? So volume of a sample 0.1 plus volume of diluent 9.9 over 0.1. So 10 over 0.1 gives you 100. Okay? And then we plate this. What volume do we plate? 1 ml gets plated onto the agar plate. And how many colony forming units do we get out of it? 243. CFU. Okay. Just trying to fit. Okay, perfect. So, sample concentration then, how do you calculate it? What do you put on top of the first fraction? 243 CFU, very good. What do you put in the denominator, the bottom? 1 ml, which we added to the plate. And what do you do with dilution factors? Times 10 times 100. And that gives you 243,000 colony forming units per ml. Okay? Make sense, everyone?